All right, so I'm going to share our experience on SGRT with the Halcyon, and then talk a little bit about the future, some potential futures of SGRT. As you heard in my introduction, basically what that summarized as I'm an administrator. So all of the great work that we do in our clinic is done by other people. In particular, Grace was instrumental in, from the physics side, in implementing Halcyon and SGRT for Halcyon. And then Matt Taylor, who you heard from earlier, is the expert on the therapist side that is leading the team there. So I'm going to ask them to please comment at the end or during the presentation if I lead folks astray with any of the technical details during the treatment. So this talk is really primarily about technology evolution. So back in 2009, 2009, we started with our SGRT program with the early version of the camera system. That has progressed through the years as Varian has introduced new technologies. We had SGRT or have SGRT on our TrueBeam. And then in 2017, we had the Halcyon delivered. And that came in pieces, as you can see here, and was delivered in August 12th to be exact. Our first patient was treated on September 22nd of 2017. And then because of some California state regulations, we have to wait about 20 days to have the state approve what our commissioning and calibration documentation. So what you can see here is this basically is commissioned and clinically implemented in 2 weeks. And that has some pretty significant implications on the future of radiotherapy, but also the future of SGRT, which we'll talk about in the next few slides coming up. These are the patient disease sites that we've treated to date and the number of patients. As you can see in this slide, this shows the breakdown of the cases that we've treated. So we've treated head and neck, abdomen, lung, some palliative cases, quite a few prostate cases as well. We're an academic center, but a very busy clinical site. We have 4 machines. We treat anywhere from 170 to 190 patients per day on those 4 machines, so efficiency is king for us. The Halcyon runs about 10 to 12 hours per day, depending on our current patient load, and we've treated up to 60 patients a day on that one machine in 12-hour time slot. So if you do the math, that's about 8 minutes per patient treatment on average in and out of the room with the Halcyon. So very efficient device. I was recently at ESTRO, the ESTRO meeting in Europe last week or the week before, and talked to some other early Halcyon adopters, and these data are very consistent across different centers, both within the US and within Europe. We have a robust online machine reporting system, so anytime there's a fault at the machine, even if it doesn't bring the machine down, therapists can log that, and we just keep track of all of our issues with the machines. And you can see on this slide we have 2 TrueBeams. Those numbers under there are the serial numbers of the TrueBeams, so it kind of gives you an idea of what version of the equipment that we have. So we had the 18th TrueBeam, and we have the 29th TrueBeam, and then the 4th Halcyon that was delivered. And we're getting about, on the TrueBeams, 4 to 5 fault submissions per week for each of the TrueBeams. And then for the Halcyon, it's significantly less. And just for fun, we have the same system is used for when a line RT gives a fault or goes down, and it's a little bit less for the Align RT system, so we're pretty excited about that. I get that question sometimes, how robust is Align RT if you're using it as part of your routine clinical care? Is the Align RT go down? Does it have faults? The answer is yes. Every piece of equipment has faults, but you can see here it's much more robust than our Linux, so it's really not the issue clinically that we are dealing with. Okay, I'd like to transition now into just walking through a case of how we use SGRT with the Halcyon. So when the Halcyon was delivered, we were lucky to also get funding for a 2-camera system in the Halcyon room. And the cameras are on either side. Those are just conventional cameras that we use in our other treatment rooms, and those cameras on either side of the Halcyon device. And the first thing we noticed is that, I'll walk you through this, this pathway. So the patient gets a CT scan, that data is sent over to Eclipse. We export the DICOM objects over to Align RT and dosimetry to get the surface contours and the structures, and then those structures are pulled from that database at the treatment machines when we need it. The problem is that an element in the DICOM object was changed from when you export to the Halcyon, and that DICOM object is used by Align RT to verify whether that DICOM object is correct or not. And so in order to use the Halcyon, SGRT on the Halcyon right now, you have to manually change an element in the DICOM object. So right now it's a little bit of a kludgy workflow in order to get it to work for Halcyon, but it's an easy fix. It's just basically bookkeeping type of thing. So that should be being fixed in the near future, and then it'll be the same workflow as we have for the TrueBeams and the other devices. So moving on to the process of treating a patient with SGRT on the Halcyon. This was a brain patient that we are treating. The therapists right now are requesting certain cases that we use Align RT on because it takes extra work for physics to grab that DICOM object, change it, make sure that it's working and well, so it doesn't follow the same workflow. So we're trying to limit the number of cases and only use them on cases that the therapists think are absolutely beneficial. So that's typically brain, sometimes head and neck cases. And so the first thing that happens, just like a regular case, you open up the patient in Align RT at the treatment machine. The therapists go into the room and open up the patient on the Halcyon system, get the immobilization stuff ready, and then the patient is placed on the table and they get the initial positioning set up. Again, all this happens outside of the treatment bore, so the patient is not inside the treatment bore. And once they get the patient basically set up, they make sure the mask is off, and then they on the left side there, and then one of the therapists will turn on the Align RT system and start monitoring the patient. And they make their large adjustments with the Align RT system guiding the adjustments for the patient. And what they're trying to do here is not necessarily get the patient, because the patient doesn't have the mask on at this time, but they're trying to focus on the pitch, roll, and yaw, because we don't have a 6-degree couch on the Halcyon. It's just a straight translational couch. And so they're primarily looking at pitch, roll, and yaw, and getting the pitch, roll, and yaw within the limits. And once that's in there, they put on the mask, and they go outside the treatment room, and patient slides into the bore for treatment. The patient is imaged for every fraction, and then the treatment proceeds. So again, our average treatment time is about 8 minutes. So even for the cases that we're doing this in, on average, getting 60 patients through the treatment is a pretty significant accomplishment, and speaks to the workflow of not only the Halcyon, but also the Align RT system. So moving on to the future, it's always tricky to talk about the future. I don't like to do it because there's really only two options. Number one, you could be wrong, which happens a lot. And number two, even if you're right, when people look back, they say, oh, that was obvious. And of course, everybody knew that was going to happen. So you can break these down into two kind of broad areas, right? What's the short-term future for SGRT? What's the long-term kind of crazy, out-of-the-box type of thing? So I like to touch on both of those. And it's always fun when you kind of give these talks to look back on where our program evolved from. This was on the left there is the data from the first patient that we ever treated, our first radiosurgery patient that we ever treated with Align RT and SRS. On the right is just a volunteer that was helping us when we got the program up and going. So this was a brain patient. It was a retreat, actually, a target against the brainstem. Of course, the most difficult case that you could possibly do, but there were no other options, and the patient didn't want to go through the conventional immobilization that we were using at the time, so they were a good candidate for this. It's interesting to look back. This was our original thought about how we're going to use surface imaging for cranioradiosurgery. The idea was patient on the table, no mobilization, and let's go for it. We treated the first handful of patients like that, I think 2, 3 patients, something like that, maybe 5. It worked. The treatment was interrupted, obviously from time to time because there's no immobilization. But we found a bigger problem, is that patients were so comfortable they were falling asleep. And once you fall asleep, what happens? You start dreaming and twitching all over, and it didn't work at all, right? So we quickly iterated to having an open masking system, and you can see why we are comfortable having such an open mask. You know what, I'd like to, at least our viewpoint, my viewpoint, I won't speak for Grace and Matt, you can see it differently. If you're using surface-guided radiation therapy and you're worried about rigid immobilization, you're missing the point. It's not about immobilization any longer. It's about patient comfort, it's about efficient treatment, and it's about monitoring the patient in real time so that if they move, you stop the beam. It's a whole different mindset, right? And I think we've heard throughout the conference here that, the more you try to make somebody immobilized, the more they're going to be uncomfortable, the more they're going to move. There's a lot of qualitative experience around that idea, so I don't think that's anything new. Looking at some of the presentations that I gave back in 2009, 2011, I had some ideas already on what the short-term and long-term futures of SGRT were going to be. The slide, or the picture on the right is a long-term future. Why do we even need CT SIM anymore? Just bring the patient in the room, monitor them in real time with SGRT, get a cone beam CT, and treat away. That should be the future. So that's the first idea that pops into head. Why can't we just do that? It was actually a longer term idea to say, well, maybe we should also be using this with SBRT. And SBRT is quite a bit different from a philosophical standpoint related to treatments, because now you have to correlate external surface with internal anatomy. And so that's a challenge. How do you do that? I mean, Align RT, I think, can be used today for SBRT, but that correlation between internal anatomy and external surface still needs to be worked on and addressed. So some short-term futures. These are obvious. Things that, in some cases, like I've heard, or we've heard throughout the conference, are already happening today in some centers, right? Every patient, every fraction. Pre-treatment setup, no longer marking the patient, no longer tattoos, lasers. I'm looking forward to the day when we get a delivery of a LINAC and it has no lasers, right? What are we doing with lasers in the treatment room in 2018? Intrafraction motion monitoring will be essential and used for every single patient. Bolus setup, verification, and then Align RT and surface-guided radiation therapy in the broader aspects of all board-based systems, MR-Linacs, protons, cyberknives, et cetera. So this is something that needs to happen in the near-term future. The next is SGRT should be the default system for 4D CT and gated treatments. It's used for that to some degree. There are other solutions out there, but this idea of working on the correlation between external surface and internal anatomy will allow us to be able to use this for appropriate treatment sites for every patient and every fraction. Collision prediction, detection, avoidance, it's a problem that's been with us as long as we've had LINACs. It's a particularly difficult problem to solve, and I actually thought that this might be better placed in the long-term solution. So take your pick. It's a short-term need that we all have in our clinics, but solving this is difficult, and it may actually end up in the long-term bucket. And then lastly, when we talk about SGRT, you have to broadly think about what is surface. Surface is anything. It's the face. It's what you look at. It's detecting where people are and what they're doing, et cetera. So patient identification, patient verification is a short-term future for SGRT. And we've already seen SafeRT out in the hallway. If you haven't seen it, check it out. It's pretty cool technology, and I think it's going to be used widely in clinics. Okay, let me transition here, starting to get to thinking about long-term. And it takes me back when I start to think about long-term applications of SGRT. Just bear with me with the toaster here. I'll get to it in a second. When I started in the field in the early 90s, you'd get a LINAC, and the physicist brings out this water tank, as you'd measure for hours and days, and then you get the data into the planning system, and you're tweaking things, and meanwhile the clinic is yelling at you, when can we use the device, and why is it taking so long? And I used to tell the physicians, it's not a toaster. You have to do a lot of work on these things. They're very complicated. You don't just plug it in and turn it on. So just relax. We're going as fast as we can. We got to be safe and accurate. Well, fast forward to 2018, right? What do we have? We have a toaster, right? I mean, you plug it in and it works. So that starts to change your thinking. What happens when complexity is buried deep within the product? How should that change our thinking? Should we do the same thing that we've always done? Well, of course not. Now we have to think about what else do we do? What does this enable us to be able to do differently? Well, we're going to have automation. Things are going to be done faster. They're going to be done more consistently. And we're going to have a lot of simplifications. And so we need to leverage that. Grace and I submitted an abstract to this last AAPM where we did a systems engineering safety assessment of the Halcyon and SGRT. The details of it aren't important to discuss for this presentation, but the broad take-home message from our initial analysis is that it is not the equipment that is causing us problems in our clinic. It is the workflow. That's perhaps obvious when we say it aloud, but taking safety systems that they use in airlines and all these other things and applying it, becomes crystal clear. The equipment is no longer our biggest problem. That's not to say it could never fail, but it is the workflow that leads us down the path to suboptimal treatments and then accidents. So we need to look at that in terms of what are the long-term implications or changes of SGRT. So there's some possible long-term opportunities. One is workflow facilitation and monitoring, right? Where is the staff? Do you have the right patient in the room? That's a surface imaging thing, right? You detect your face. Anybody who has an iPhone 10 now knows that it's my face that opens my phone. Same thing for SGRT. It's going to be your face, the patient's face, that allows you to treat the patient. But once you're tracking the patient, you can also track the staff, right? You're detecting the surface of patients and staffs. Now you can track the staff where they are. So there's this whole notion of where is the patient? Is it the right patient? Where is the patient? How long is it taking to do work? And when are there workflow disruptions that, as a clinic, you need to know about so that you can address so that inaccuracies or bad things don't happen in the clinic? This is a possible long-term future that needs to happen, but it's already started with SafeRT and the information flow that's going to come out of that. Another interesting possible long-term solution or opportunity for SGRT is detecting the patient's health from just looking at their face, right? Why should it be us that have to ask the patient, how are you feeling today? I mean, it's good to build a bond with the patient, but wouldn't it be great to have a system that is already telling you, hey, Mr. Jones is dehydrated. Mrs. Smith is feeling anxious about her treatment today. The system just notifies you that, and then you can start to take the next step in terms of, okay, what systems can we put into place in order to, once we learn about their current state of mind or state of health, we can start to proactively address those type of issues. Kind of an interesting aspect of a future of SGRT. And then what else? I mean, it's wide open. We're talking years into the future here, but the future is sometimes a lot closer than you think. And the butterfly that we have on the screen reminds me about the butterfly effect. And I think it comes out of economics, but basically what it is that if a butterfly flaps its wings in Atlanta, you can trigger a hurricane in Australia, right? Just because of the complexity of the world and how everything fits together. So one small change can completely revolutionize how something happens around the world. And that's the same thing with long-term futures and great ideas. In this room exists a butterfly that is going to flap its wings and set the field of SGRT in a trajectory that's going to revolutionize radiation therapy. So, in closing, my last two slides, This is a slide that I use when I talk about the virtues of knowledge-based planning and automated types of treatment planning, but it also applies to any kind of aspect, an SGRT aspect of care or quality or safety. So SGRT is one of those. In anything that we do, and let's just take this as radiotherapy, the x-axis could be time, it could be dose, it could be the difference between the prescription and the treatment dose, et cetera. But you have a distribution of how things work. Some cases are not so good, and other cases are great. As we implement SGRT and the future of SGRT, what we're going to be doing is doing things more accurately. The distribution is going to be narrow. More patients are going to get consistently excellent treatment, and that excellent treatment is going to have a very small variation around the optimal case. So that's where things are going with SGRT. You're going to have more comfortable treatments, they're going to be more efficient, you're going to have safer clinics, greater accuracy, and better outcomes. So in summary, SGRT has an important role in Halcyon treatments. I think we've seen that even with the initial aspects that we have experience with thus far. The short term of SGRT will certainly revolutionize radiation therapy, but the long-term future still is being defined, and we need input from the community in order to figure out what is absolutely the best way to go forward in the future. And lastly, recently we finalized moving forward with a textbook on SGRT. So that you've all stuck around. You can be hearing from me about potentially contributing to the textbook, so please answer my emails if you hear it. But we think this is a really exciting opportunity for the field of SGRT because it has reached critical mass, and it'd be a great way to kind of have a textbook that would be able to capture where the state of the field is today and provide a resource for the field. So with that, I'd like to thank you very much, and be happy to answer any questions.